Okay, this video, what we're going to do is we're going to be graphing using the over, up, down table by sliding the starting point. Now we're going to slide the starting point by adding or subtracting. So our first equation is y equals x minus 3 cubed plus 2. And we're going to find that the 3, which is in with the x, slides it. But it slides it in the x direction, but anything in brackets slides it opposite. It really is line. So when it says negative 3, it really slides it horizontally plus 3. Anything outside of brackets doesn't slide. So if this says I'm going up 2, I'm going to go up in the y direction 2. Once we've done that, this guy has done his job and this guy has done his job. So we're really left with a y equals x cubed equation starting at a new starting point. So we'll go over to the graph here, and instead of starting at 0, 0 where we used to go, we're going to go over 3 and up 2, and we're now going to do a y equals x cubed graph, but starting there. So let's look at the over up table for y equals x cubed. So if I go over 1, I'm going to go up 1 cubed, which is 1. If I go to the right 2, I'll go up 2 cubed, which is 8. If I go to the right 3, I'll go up 3 cubed, which is 27. If I go to the right 0, I'm going to go up 0 cubed, which is 0. If I go to the left, I'm going to go down, because negative 1 cubed is negative 1. If I go to the left 2, I'm going to go down negative 2 cubed, which is negative 8. And if I go to the left 3, I'm going to go down negative 3 cubed, which is negative 27. So starting with my new starting point, I merely do the following. I go over 1, I go up 1. I go over 2, I go up 8, 2, 4, 6, 8. That's going to take me to 10 because I started 2 above. If I go over 3, 1, 2, 3, I'm going to go up 27. 2, 4, 6, 8, 10, 12, 14, and that's going to take me right off the graph. If I go over 0, I'm going to go up 0. Go to the left 1, I'm going to go down 1. Go to the left 2, I'm going to go down 8. 2, 4, 6, 8. That'll take me to negative 6 here. And if I go to the left 3, 1, 2, 3, I'm going to go down negative 27, and that'll take me off my graph. So here is what the equation looks like. It goes right through there and right through there and heads off to negative 27 and heads up to positive 27 there. So it's just like the y equals x cubed graph that we saw in the last video, except it has, or in the first video, but except it starts at a new starting point. Now for my second example, the same idea works. This time it's y equals 2, x to the power x plus 1, subtract 2. So it's an exponential equation. We will think of the exponent as being in brackets. If you put this into your graphing calculator, you would have to put that exponent in brackets. So again, the starting point, because it's in brackets, that's going to lie. It's going to go 1 to the left. And the minus 2 is outside of the brackets. It doesn't lie. So it's the new starting point will be negative 1 and to the left and negative 2 down. So I can go over and go negative 1 and negative 2, and this is my new starting point right here. And we're going to find that we have an asymptote line that goes right through there. I'll make it the green dotted line here. That's going to be our new asymptotic line. Okay, by starting at negative 1 and negative 2, that's done its job and that's done its job. We really have a y equals 2 to the x graph. And here is the over-up table from that. So I go over 1, I'm going to go up 2 to the power 1, or up 2. Go over 2, I'll go up 2 to the power 2. which is 4. Over 3, I'll go up 2 to the power 3, which is 8. Over 4, I'll go up 2 to the power 4, which is 16. If I go up 0, 2 to the power 0 is 1. So I'm still going to go 1 above my starting point. Left 1, I'm going to go still up 2 to the power negative 1, but that's equal to a half. Left 2, 2 to the power negative 2 equals a quarter. Left 3, 2 to the power negative 3 equals an eighth. And left 4, 2 to the power negative 4 equals a 16th. So let's see how this works. Remember, we are now not starting at 0, 0. We are now having a new starting point. So from here, if I go over 2, I'm going to go up 2. Sorry, if I go over 1, I'm going to go up 2. If I go over 2, I'm going to go up 4, 2, 4. If I go over 3, 1, 2, 3, I'm going to go up 8, 2, 4, 6, 8. And if I go over 4, 1, 2, 3, 4, I'm going to go up 16, 2, 4, 6, 8, 10, 12, 14, 16. So our graph is going to be curving around like that, but it doesn't go through the starting point, because when I go over 0, I go up 1. And if I go to the left 1, I go up a half. To the left 2, I go up a quarter, then an eighth, then a 16th. And my graph actually looks like this. It comes in through here, curls 1 above the starting point, and becomes asymptotic there, and then takes off that way. So the asymptote is like that, and there is my exponential graph with a new starting point. Okay, the third in our series is a reciprocal graph with a new starting point. So y equals 1 over x plus 4, all plus 3. Now, when you put this into your graphing calculator, that's going to have a bracket around it. So bars are like brackets. So our new starting point, take the opposite of that. It's going to go to the left 4, but take the same as that. It's going to go up 3. The plus 4 has done its job. The plus 3 has done its job. So it's really y equals 1 over x. It's a reciprocal equation, but drawn at a new starting point. So let's go to our equation here. Our new starting point is negative 4 and positive 3. 1, 2, 3. Okay, I haven't put these numbers in here. 2, 3, 5, 6, negative 1, negative 2. Okay, so here's what our over, up, down table looks like. I go over 1, I go up 1 over 1. I go over 2, I go up 1 over 2, which is a half. I go over 3, I go up 1 over 3, which is a third. If I go to the left or right 0, I go up 1 over 0, which is a no-no. So for real numbers, there's nothing that exists at that point. If I go to the right a half, I go up 1 divided by a half, which is 2. If I go to the right a third, I go up 1 divided by a third, which is 3. If I go to the left 1, I'm going to go up 1 divided by negative 1, so I'm going to go down 1. If I go negative 2 to the left, it'll be 1 divided by negative 2, which is negative a half. I'm going to go down a half. Left 3, it'll be 1 divided by negative 3. I'm going to go down a third. Left a half, I'm going to go 1 divided by negative a half. It means I'm going to go down 2. And left a third, I'm going to go 1 divided by negative a third, which is down 3. So here's what my graph looks like. It's going to have the starting point move to negative 4 and plus 3. So I'm going to put some asymptotic lines here, sort of like crosshairs, and that's where I'm going to aim my graph at. So starting here, over 1, up 1, right 2, up a half, right 3, up a third, right 0, nothing happens, right a half, I go up 2, right a third, I go up 3, right a quarter, I go up 4, etc. So this graph is an asymptote there, curls around, and it becomes an asymptote here. However, when I go to the left one, I'm going to go down 1. To the left 2, I'll go down a half. To the left 3, down a third. To the left 4, down a quarter, etc. To the left a half, I go down 2. To the left a third, I go down 3. To the left a quarter, I go down 4. And we get another half to our graph, an asymptotic line that way. So there is that graph now. So you can see that adding or subtracting merely shifts the starting point to a new spot. Now we will put this all together by flipping, shrinking, stretching, and sliding with the 4th video in this series. So please watch it.